Hey there, Mr. Sutton here, bringing you the IM374 Extra Practice number 7 solutions on applications of right triangle trigonometry. Let's take a look at the puzzle that's going with this one. So here's our puzzle. It's a definition decoder, whatever that's supposed to mean. So we have Europe, and then there's supposed to be some phrase that comes after that, and underground garage, and another phrase that comes after that. Now, in order to find the phrase, we have to basically figure out the missing angle or the marked angle in all of these triangles. Even in these word problems here, that's really all it amounts to, although some of them are trickier than your conventional problem. Once we find the angle, we have to look it up in these boxes above, and the letter that's next to that problem, we'll just put that under that angle when we find it up above here. So if I do this problem n and I figure out that the answer is, I don't know, 9, then I would go to this 9 degrees here and put n's in for both of those. We do have to be careful because some of these angles do appear more than once. So with that said, let's get on our way. Here's our opening problem. We're given this triangle, trying to find this lower left angle, and we have a 3 and a 5 to go with us here. So for all these problems, because these are all right triangles in which I'm given two sides and I'm looking for an angle, I'm going to use SOHCAHTOA. So that gives us all of our trig ratios at once. So I'm just going to keep this written up here for the duration of solving this puzzle. SOHCAHTOA. We've got the opposite side here, the side across from the angle. We also have the hypotenuse. So that's going to be sine equals opposite over hypotenuse. So we have sine of our missing angle equaling 3 over 5. Now to find theta, I have to do the inverse sine of 3 over 5, and for that I need the calculator. So here's my calculator. Now since this is my first problem with this puzzle, I'm going to go ahead and check to make sure I'm in the correct mode, which should be degrees because all the answers they want are in degrees. So let me go to mode, and it looks like I'm in radians right now, so let me arrow down and switch that over to degrees, press enter, and then I can clear this out. So now it'll give me answers that are in degrees rather than radians. So now to get sine inverse and all the inverse trig functions, I have to first press second and then the trig function, so second sine in this case, and then we've got 3 divided by 5, and you can close the parentheses if you want, but it's not necessary. Press enter, we get 36.8 and some change, but they said round to the nearest degree, so we'll call that 37. So 37 degrees. So we're putting an n under 37 wherever we see that. I see one of those right here, and I don't see any more 37s, so it looks like this one's done for now. Now we're doing problem U. So for this triangle, we again have the opposite and hypotenuse, so we're using sine again. So we can write sine of theta equals opposite side 4 over hypotenuse 11. So then theta is going to be the sine inverse of 4 over 11. So if I go on the calculator and plug all that in, and I'm going to do this off camera, now that we've seen how to do it for one of them, we can do it for all of them, and then press enter. That gives us about 21 degrees for this one. And 21 degrees, that's right here, so we're getting a U right there. And oh, wait, there's another 21 over here, so another U. We get to use that one twice. Here we go now with problem C. This one we have the adjacent side, the side that's touching the angle but not the hypotenuse. We also do have the hypotenuse itself, so that's cosine equals adjacent over hypotenuse. So cosine of theta is going to be adjacent side 5 over hypotenuse 8. And then theta itself will be cosine inverse of 5 over 8. So plugging that in, I end up with about 51 degrees. So 51. And then 51, where do I see that? Not up top. We see it, there's only one of them, it's right there, so that's a C. Now for problem O. In this one, we have the opposite side and the adjacent, so we need TOA, tangent, equals opposite over adjacent. So we have tan of theta equaling opposite side 9 over adjacent side 10. And then tan inverse of 9 over 10 is going to give me my theta. So tan inverse of 9 over 10, that's going to come out to about 42 degrees. And 42 degrees, I see that right here, so there's an O. Any other 42s? There's another one, there's another O. And then I see another 42 down here as well. And I think that's it for 42s. So we're moving on. Problem Y, based off of the angle up here, they changed the position a little bit. They have given us the adjacent side, the touching side, along with the hypotenuse. So that's going to be cosine. So we can write cosine of theta equals adjacent side 13 over hypotenuse 15. So then cosine is inverse, or theta is inverse cosine of 13 over 15. Cos inverse of all that is giving us 30 degrees if we round it off. So we have y going under 30, so right there. And then are there any other 30s around here? Nope, not surprised. Y is not a very common letter, so we keep going. Now we're doing problem P. This time around, based off of this angle, we have the opposite side and the adjacent. So tangent, TOA. Tan of theta equals opposite side 50 over adjacent side 20. So then theta equals inverse tan of 50 over 20. So tan inverse of all that is going to give me 68 degrees. And then 68 degrees, I don't see that in the top row. Down here, I've got a 68 toward the end, so there's a P. For this problem, we have a very small angle there, and they've given us the side that's opposite and also the hypotenuse. So that's going to be sine. So we have sine of theta equaling opposite side 1 over hypotenuse 12. Theta then is going to be sine inverse of 1 over 12. And then running that on the calculator is going to give me 5 if I round that off. So 5 degrees. And that's A. So let's see here. We've got a 5 right there. There's an A right there. We also have another 5 down here, so another A. And another 5 here. There's another A. And are there any more? Yep, one more towards the end. So we got 4 A's in this one. Nice. Okay, time to take on problem W. For this one, we have the hypotenuse for sure. And based off this angle, this 21 is the adjacent side. It's touching the angle. So again, we're using cosine. So we have cosine of theta equaling adjacent side 21 over hypotenuse 30. Theta then is going to be inverse cosine of 21 over 30. So let's see what this comes out on my calculator. That's going to be 46 degrees if I round it. So we've got 46 is going to be W. No 46s up here. Down here we've got a W right there at the beginning. And another W here. Nice. I think that's it. Okay, time to take on problem W. For this one, we have the hypotenuse for sure. And based off this angle, this 21 is the adjacent side. It's touching the angle. So again, we're using cosine. So we have cosine of theta equaling adjacent side 21 over hypotenuse 30. Theta then is going to be inverse cosine of 21 over 30. So let's see what this comes out on my calculator. That's going to be 46 degrees if I round it. So we've got 46 is going to be W. No 46s up here. Down here we've got a W right there at the beginning. And another W here. Nice. I think that's it. For problem I, based off this angle, we've got the opposite side and hypotenuse. So that's going to be sine. So sine of theta equals opposite side 25 over hypotenuse 45. And then theta is inverse sine of all that. So plugging all that in gives us about 34 degrees, 33.7 and some change. So 34 for I see a 34, let's see, where is one of those? Right there, just one of those. You would think there'd be more I's, but I guess not. Now we're on to some of these so-called word problems, where really you just have to look at the diagram and find the angle, but here's the backstory. So this is a driveway built on an incline, rising 3 meters over a distance of 20 meters. We want the angle of elevation of this driveway. So we have the opposite side and the hypotenuse for this triangle. That's the sine function. we have sine of theta equaling opposite side 3 over hypotenuse 20. So then that angle of elevation is going to be sine inverse of 3 over 20. And then if I put all that in my calculator, that's giving me a value of 8.6, so 9 degrees. So wherever I see a 9, I'm going to write an L. Let's see here. There's no 9s up top. We have a 9 here, and 2 more 9s here and here. So lots of 9s, getting some L's here. A few of these last couple problems are a little bit tricky. So in this one, they have a step of a staircase rising 16 centimeters for a tread width of 36 centimeters. So there's our diagram. We want to know the angle the stairway makes with the floor, this angle down here. Now the tricky part is they didn't give us anything about this triangle that this angle's part of. However, one thing that we do know, since this stairway line here and the floor are parallel with each other, and they're being crossed by this transversal, that means this angle and this alternate interior angle are congruent, are the same. So if I can figure out this angle in here, which I can because I've got all the info for that triangle, then I can just copy that and that'll be this angle down here as well. So for this angle inside, we have the opposite side and the adjacent, so that's TOA, tangent. So we have tan of theta equaling opposite side 16 over adjacent 36. So then tan inverse of 16 over 36 will give me the angle I need. And once I plug that in, I get a value of 24 degrees. So that's my angle of elevation of the staircase. So for R, we're putting that in the 24 right here, and another 24 here. And is that it for 24s? It looks like, oh, no, one right there. Okay, now we got it. On this one, we have a roof constructed like the diagram shows. We want the pitch, which is the angle of elevation of the roof. Oh, good to know. I didn't know that's what that was called. So we've got the opposite side, and we also have the adjacent side, not the hypotenuse. So that's going to be TOA, tangent. So we can write tan of theta equals opposite side 10 over adjacent side 16. So then inverse tan of 10 over 16 gives me the pitch of this roof. So plugging that in, I end up with about 32 degrees, very close to 32 degrees, not much rounding needed there. So 32 is going to get a B. So we have a 32 right here, that's a B. And I think that's it for 32s, just one of those. And now, if you can believe it, we've come to the final problem. We have all these blanks still, but the one thing you have to keep in mind with this puzzle is not all the blanks are going to get filled in. So now we're seeing what gets this final T. We have a train decreasing its altitude by 8 meters when traveling along 200 meters of track. We want the angle of depression of this track. This is kind of like that problem with the staircase. This line up here and this line down here are parallel. So this angle and this angle here are the same angle then. And that means we can use this lower triangle to figure out our answer. So based off of this angle down in the lower right, we have the opposite side and the hypotenuse. So that's going to be our sine function. So we have sine equals opposite 8 over hypotenuse 200. So then we have sine inverse of 8 over 200. And plugging that into my calculator, sine inverse 8 over 200 comes out to not a very big angle. That's like 2 degrees right there if you round that off to the nearest degree. So 2 is getting a T. So right there, you get a T, and you get a T, and you get a T. And then we have a T here, and another T at the very end. And now we're ready to solve our puzzle here. So we have the phrase, you're up, and then your turn to bat. Oh, like you're up to bat. And then down here we have underground garage, wall-to-wall carpet. Like a carpet that you would put on your floor, only it's also a carpet because it's underground and you're parking cars there. Oh, this is delightful, very delightful. All right, until next time, Mr. Sutton signing off.